Welcome back to another math lesson hosted by Book and Table. I am your math tutor, Maurice Wright, and in this chapter we are going to review 3x3 systems. We are going to take a look at the back substitution and substitution methods, and then we'll also have a look at the elimination method for solving 3x3 systems. Should you have any follow-up questions, feel free to leave them in the comments section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. So let's begin by reviewing 2x2 systems. 2x2 systems consist of two lines, or a line and a quadratic in the same plane. The solution to a 2x2 system is the point or the xy coordinate where the lines intersect. So we have a two-dimensional plane here, our x and y axes, and we have two lines that have a solution here, the point where they intersect. We can also have a line and a quadratic intersect, and the solution would be the point where they do so. Now we have two equations with two variables in 2x2 systems. So for example, this could be a 2x2 system. We have one equation and then a second equation, and they each have two variables. The variables have the same exact value in each equation. A 3x3 system is not much different. 3x3 systems have three equations, each of which has three unknown variables. So for example, x plus y plus z is equal to 4 could be equation number 1. X minus y minus z is equal to 3 can be equation number 2. And 2x plus 2y minus z is equal to negative 1 could be equation number 3. And for all three of these equations, each variable has the same exact value in each one. So throughout this chapter, we'll take a look at several different methods we can use to find the individual values of each variable for these equations. Now the solution to a 3x3 system is a little bit different than the solution to a 2x2 system. Since in a 3x3 system, we are working in three-dimensional space now instead of a two-dimensional plane. So 3x3 systems are three planes located in three-dimensional space, and the solution is the point or the x, y, z coordinate where the three planes intersect. So let's say we had one plane, this orange plane. We had a second plane, this green plane vertically here. And then we have this blue plane perpendicular to the green one here. So we have three planes moving in three different directions in this space. And where all three planes intersect, that point right here, this would be the solution to this system. It is the only place where all three planes intersect. So for example, out here, only the orange and blue planes intersect on this side as well. And if we're moving up and down here, this is where the green and blue planes intersect. This point right here, we have the green plane existing, we have the blue plane existing, and we have the orange plane existing, and it's only in this one point. So when we can pinpoint a single coordinate in a three-dimensional space for a 3x3 system, that is what is considered the solution to the system. Now let's discuss a few scenarios that would create a lack of solutions. A 3x3 system does not have a solution if there is no single point, x, y, z coordinate, that lies in all three planes. So what are some of the scenarios that can produce this outcome? For one, if we have three planes that are all parallel to each other, then we don't have any planes that intersect. So this scenario would not produce a solution. We can have a scenario in which two planes intersect. So we have this plane here and this plane here that are parallel, so they never intersect each other. And then we have a plane that cuts through both. So here, two planes intersect. Here, two planes intersect. But there's no point where all three intersect, since this plane and this plane won't cross each other. And this is another situation where all three planes are crossing each other, but we don't have a place where all three intersect. So we have one plane coming down this way, one plane going towards the back, and another plane going horizontally through both. Here, the flat plane and this front plane cross. Here, the two vertical planes cross. And back here, our flat plane and the plane in the back cross. But there's no point where all three of these cross each other, so there would not be a solution to this system either. If a false statement is produced during the substitution or elimination method, then there are no solutions to the system. This is what we call an inconsistent system. So we'll get into the substitution methods and the elimination method in a moment, but keep an eye out for statements such as 0 is equal to 4, 0 is equal to -2, 0 is equal to 1. If you wind up with any of these kinds of statements, this is the indication that you do not have any solutions to this 3x3 system. Now on the flip side, there will be several scenarios that can produce an infinite number of solutions for 3x3 systems. A 3x3 system has an infinite number of solutions when two or more planes intersect at all points along a common line. So in this scenario, we have plane number 1, plane number 2, and plane number 3. And you'll notice they're all positioned in the same direction. They're all vertical. So now this allows for when they intersect, you have a line that goes infinitely north to south. These planes are not restricted to what you're seeing. They extend infinitely in all directions. So at this point here, you have an infinite number of points going north and south where all three of these planes intersect. So thus, there are an infinite number of solutions to this system. And there are several other scenarios that can produce an infinite number of solutions, such as two planes coinciding with each other. So they're the same plane. So here we have two planes that are the same, and they're intersecting another plane. Again, all of these planes are positioned the same way. So when they intersect, you have an infinite number of solutions. And you can also have all three planes coinciding. So in this image, it looks like these are stacked on top of each other, but this represents all three existing in the same exact place. And since all three of these planes exist in the same exact place, that lets you know that each point in the plane is a solution to all three planes. Thus, there are an infinite number of solutions in this scenario where all three planes coincide. Now, for infinite solutions, if a true statement is produced during the substitution or elimination method, then there are infinite solutions to the system. So this will produce a statement such as 0 is equal to 0. So if you wind up with a statement such as this one while you are doing the algebra, then you know that this is a system with an infinite number of solutions. So these are the different scenarios that we'll be encountering throughout the remainder of this chapter. Let's now begin discussing back substitution. Some 3x3 systems can be solved by substituting the value of one variable back into another equation to solve for an unknown variable. So let's say we have this 3x3 system here. Equation A is x plus y plus z is equal to 6. Equation B is 2y minus z is equal to 1. And equation C is z is equal to 3. Now, back substitution can be utilized when at least one of our equations provides us with the exact value for one of our variables. So since we know z is equal to 3, then we can substitute 3 in for z into either equation B or A for z. And when we do so, equation B has one unknown variable y, and equation A has two, x and y. So because equation B only has one unknown, we are going to solve equation B first. This will allow us to solve for y, and we already have z. And then we can substitute both of these variables into equation A to solve for x. So for back substitution, you take the equation that provides the value of one variable and you substitute that value into the equation that has only two variables, the variable you were being given being one of them. And then you take those two variables and you plug it into the equation that has all three variables. And by the end of that process, you'll have the values for all three variables. So let's take this system and solve it step by step. You'll be asked to solve by substitution and check the answer. Equation A, x plus y plus z is equal to 6. Equation B, 2y minus z is equal to 1. In equation C, z is equal to 3. So step 1, substitute z into equation B here. And then step 2, solve for y. So when we plug 3 in for z in equation B, we get 2y minus 3 is equal to 1. And now to solve for y, we'll add 3 to both sides, giving us 2y is equal to 1 plus 3, which is equal to 4. And now to remove this coefficient of 2, we'll divide both sides by 2, giving us y is equal to 4 divided by 2, which shows us that y is equal to 2. So once we substitute z into equation B and solve for y, we have two of our three variables solved for. So to find x, we want to substitute y and z into equation A and solve for x. When we do so, we get x plus 2 plus 3 is equal to 6. 2 plus 3 is equal to 5. And now we can solve for x by subtracting 5 from both sides, showing us that x is equal to 6 minus 5, which is 1. So now we have the value for each of the three variables. X is equal to 1, y is equal to 2, and z is equal to 3. So this x, y, z coordinate would be the solution to this 3x3 system. And you want to check your answer by plugging the x, y, z, 1, 2, 3, into the original equations to make sure that you get a true statement for all three. So when we plug in 1, 2, and 3 for x, y, and z into equation A, we get 1 plus 2, which is 3. 3 plus 3 is equal to 6. So since we get a true statement, 6 is equal to 6, that confirms that x, y, and z have the correct values. For equation B, we have 2y minus z is equal to 1. 2 times 2 is equal to 4. 4 minus 3 is equal to 1. 1 is equal to 1 confirms that these are the correct values for y and z. And for equation C, we know that z is 3. 3 is equal to 3 is a true statement. So this confirms that we found the correct values for x, y, and z for this 3x3 system. So that is how you utilize the back substitution method to solve a 3x3 system. Let's now have you complete a few practice questions. Solve by substitution and check the answer. Question number 1, equation A, 2x minus y plus 3z is equal to 11. Equation B, 2y minus 2z is equal to negative 14. And equation C, z is equal to 4. Question number 2, equation A is negative 4x plus 2y minus z is equal to negative 15. Equation B, negative 5y plus 2z is equal to negative 12. And equation C, y is equal to 2. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1, step 1, substitute z into equation B here, and then step 2, solve for y. So when we plug in 4 for z here, we wind up with 2y minus 2 times 4 is equal to negative 14. Negative 2 times 4 is equal to negative 8. And now we can solve for y. So we'll add 8 to both sides, showing us 2y is equal to negative 14 plus 8, which is equal to negative 6. And now we'll divide both sides by 2, showing us y is equal to negative 6 divided by 2, which would be equal to negative 3. So after solving for y, we know y is equal to negative 3 and z is equal to 4. So now we want to substitute both of those values into equation A and then solve for x. So when we do so, we get 2x minus negative 3 plus 3 times 4 is equal to 11. And that would be equal to 2x plus 3 plus 12 is equal to 11. 3 plus 12 is equal to 15. So we wind up with 2x plus 15 is equal to 11. And now to solve for x, we'll subtract 15 from both sides, showing us 2x is equal to 11 minus 15, which would be negative 4. And to remove this coefficient of 2, we divide both sides by 2, giving us x is equal to negative 4 divided by 2, which would be negative 2. So now we've found x, y, and z for this system. The solution would be x is negative 2, y is negative 3, and z is equal to positive 4. And to check the answer, we want to plug the x, y, z, negative 2, negative 3, and positive 4 into the original equations to make sure we get 3 true statements. When we plug them into equation A, we get 2 times negative 2, which would be negative 4, minus negative 3, which would be plus 3, plus 3 times 4, which would be positive 12. Negative 4 plus 3 would be equal to negative 1, and negative 1 plus 12 is equal to positive 11. And since we wind up with the true statement 11 is equal to 11, that confirms that these are the correct values for x, y, and z. So now we move on to equation B. 2y minus 2z is equal to negative 14 would give us 2 times negative 3, which is negative 6, minus 2 times 4, which would give us minus 8. Negative 6 minus 8 is equal to negative 14, giving us the true statement, negative 14 is equal to negative 14, confirming that these are the correct values for y and z for this equation. In equation C, we know is correct, 4 is equal to 4. So this confirms that we did find the correct solution to this system. X is negative 2, y is negative 3, and z is equal to 4. And now let's have a look at question number 2. We were given equation A, negative 4x plus 2y minus z is equal to negative 15. Equation B is negative 5y plus 2z is equal to negative 12. And equation C is y is equal to 2. So step 1, substitute y into equation B here. And then step 2, solve for z. When we plug 2 in for y here, we get negative 5 times 2, which is negative 10, plus 2z is equal to negative 12. And to solve for z, we'll begin by adding 10 to both sides, giving us 2z is equal to negative 12 plus 10, which is negative 2. To get rid of the coefficient of 2, we divide both sides by 2, showing us z is equal to negative 2 divided by 2, which would be negative 1. So now we have y and z, so we just need to find x. So step 3, substitute y and z into equation A. And then step 4, solve for x. When we do so, we get negative 4x plus 2 times 2 minus negative 1 is equal to negative 15. 2 times 2 is 4, minus negative 1 would be positive 1, and 4 plus 1 is equal to 5. So we wind up with negative 4x plus 5 is equal to negative 15. And to solve for x, we'll now subtract 5 from both sides, giving us negative 4x is equal to negative 15 minus 5, which would be negative 20. And to remove the coefficient of negative 4, we divide both sides by negative 4, showing us x is equal to negative 20 divided by negative 4, which would be equal to positive 5. So the solution to the system would be x is 5, y is 2, and z is equal to negative 1. And now step 5, check the answer by plugging the x, y, z, 5, 2, negative 1 into the original equations. When we do so, we get negative 4 times 5, which is negative 20, plus 2 times 2, which is positive 4, minus negative 1, which is positive 1. 4 plus 1 is 5. Negative 20 plus 5 is negative 15. So the true statement, negative 15 is equal to negative 15, confirms that x is equal to 5, y is equal to 2, and z is equal to negative 1 for equation A. For equation B, we have negative 5 times 2, which is negative 10, plus 2 times negative 1 is negative 2. Negative 10 minus 2 is equal to negative 12, providing the true statement, negative 12 is equal to negative 12, confirming that these are the correct values for y and z for equation B. In equation C, we know is correct, 2 is equal to 2. So we found that the solution to this 3x3 system is x is equal to 5, y is equal to 2, and z is equal to negative 1. So that is how you would use back substitution to solve a 3x3 system. Let's now review the substitution method. This will help us find x, y, and z when each is present in all three equations. So we can no longer use back substitution for these cases. So what we'll do is we'll first solve the first equation for one variable, and we'll always solve for x first. And then we'll substitute this expression for x into the other two equations, b and c. And by doing so, we will wind up producing a 2x2 system, equations d and e, in which our x has been removed, and now we just have y and z. And now with this 2x2 system, we'll want to use the substitution method to solve for y and z, and then use back substitution to solve for the third variable x. So we'll take the three equations, eliminate x so that we get a 2x2 system. We'll use the substitution method for a 2x2 system to find y and z, and then we'll plug y and z into a, b, or c to find x. So let's go back to the beginning with this same exact system and walk through it together. So you'll be asked to solve by substitution and check the answer. Equation A is x plus y plus z is equal to 4. Equation B is x minus y minus z is equal to 0. And equation C is 2x minus 2y plus 3z is equal to 15. So step 1, we want to take equation A and isolate x on the left side. So we have x plus y plus z is equal to 4. So in order to isolate x, we need to subtract y and subtract z from both sides, giving us x is equal to negative y minus z plus 4. And now that we have an expression for x, we want to substitute x into equations b and c here. And then step 3, we want to create a 2x2 system with the equations from this step. So let's first plug negative y minus z plus 4 in for x here in equation B. And now we've eliminated one of our variables x, leaving us with just our y's and z's. So we can create a 2x2 system by first combining our like terms, our y's and z's. Negative y minus y is equal to negative 2y. Negative z minus z is equal to negative 2z. So we wind up with negative 2y minus 2z plus 4 is equal to 0. And when we are creating a 2 by 2 system, on the left side, we only want the terms that have our variables. So we'll remove the 4 by subtracting 4 from both sides, giving us our first equation in the 2 by 2 system, equation D, which is negative 2y minus 2z is equal to negative 4. So now we'll put this equation to the side, and now we'll plug in our expression for x into equation C here to get our second equation for our new 2 by 2 system. So we want to distribute the 2 to each of these three terms inside of the parentheses, giving us 2 times negative y, which is negative 2y. 2 times negative z is negative 2z. And 2 times positive 4 is positive 8. Minus 2y plus 3z is equal to 15. And now we combine our like terms. Negative 2y minus 2y is negative 4y. Negative 2z plus 3z is positive 1z, or positive z. Plus 8 is equal to 15. And now to create the second equation in our 2 by 2 system, we want to move this 8 to the right side. So we subtract 8 from both sides, showing us equation E is negative 4y plus z is equal to 15 minus 8, which is 7. So now we have our new 2 by 2 system with equations D and E. So we want to use the substitution method on this 2 by 2 system to solve for variables y and z. So now we want to work with D and E. So we'll put equations A, B, and C to the side for a moment. And now we want to isolate y on the left side of equation D. So we'll take negative 2y minus 2z is equal to negative 4. And we'll isolate y by first adding 2z to both sides, giving us negative 2y is equal to 2z minus 4. And now we'll divide both sides by negative 2, showing us y is equal to 2z divided by negative 2, which would be negative z. And negative 4 divided by negative 2 would be positive 2. So we get y is equal to negative z plus 2. So now step 5, substitute y into equation E here, and then solve for z. When we plug in negative z plus 2 for y, we get negative 4 times negative z plus 2 plus z is equal to 7. So now we only have z's, so we can solve for z. But first we want to distribute the negative 4. Negative 4 times negative z is positive 4z. And negative 4 times 2 is negative 8. Plus z is equal to 7. We can combine the like terms, z and 4z, to give us 5z. And now we can solve for z. So we'll add 8 to both sides, showing us 5z is equal to 7 plus 8, which would be 15. And to remove the coefficient of 5, we divide both sides by 5, showing us that z is equal to 15 divided by 5, which would be positive 3. So now that we've solved for z, we can take z is equal to 3. In step 7, we can substitute z into equation D here, and then solve for y, step 8. When we do so, we get negative 2y minus 2 times 3, which would be negative 6, is equal to negative 4. And now we'll add 6 to both sides, giving us negative 2y is equal to negative 4 plus 6, which would be positive 2. To remove the coefficient of negative 2, we divide both sides by negative 2, showing us y is equal to 2 divided by negative 2, which would be equal to negative 1. So we use our 2 by 2 system to figure out that y is equal to negative 1 and z is equal to 3. So now that we know 2 of the 3 variables, we can substitute y and z into equation A, B, or C. You do not have to plug them into all 3. You can choose any of the 3 though to plug y and z into, and that will allow you to solve for x. So I'll show you that you get the same x for all 3. So I'll work through A, B, and C here. So if we plug y is equal to -1 and z is equal to 3 into equation A, we get x minus 1 plus 3 is equal to 4. -1 plus 3 is positive 2. And now we subtract 2 from both sides, showing us x is equal to 4 minus 2, which is positive 2. So when we substitute y and z into equation A, we get x is equal to 2. You should get the same exact value for x if you plugged y and z into B or C as well. So I can show you that. So x minus -1 would be plus 1 minus 3. 1 minus 3 is -2. So we get x minus 2 is equal to 0. And to solve for x, we'll add 2 to both sides, showing us x is equal to 0 plus 2, which is 2. So we see that whether we plugged y and z into A or B, we got x is equal to 2. Same thing if we plug them into equation C, we would get 2x minus 2 times -1, which is positive 2, plus 3 times 3, which is positive 9. 2 plus 9 is equal to 11. So we get 2x plus 11 is equal to 15. And now we want to subtract 11 from both sides, showing us 2x is equal to 15 minus 11, which is 4. And to remove this coefficient of 2, we divide both sides by 2, showing us x is equal to 4 divided by 2, which would be positive 2. So we see that we got the same exact value for x, whether we plugged y and z into A, B, or C. So just choose one of them to plug those 2 variables into to solve for your third variable. And then we wind up with the solution. X is 2, y is -1, and z is equal to 3. In step 11, check the answer by plugging the x, y, z, 2, -1, and 3 into the original equations. When we do so, we get 2 minus 1, which is 1. 1 plus 3 is equal to 4. So the true statement, 4 is equal to 4, confirms that these are the correct values for x, y, and z for equation A. For equation B, we get 2 minus -1, which would be 2 plus 1, which is 3. 3 minus 3 is equal to 0. So the true statement, 0 is equal to 0, confirms that these are the correct values for x, y, and z. In equation C, we get 2 times 2, which is 4. -2 times -1 is positive 2. And 3 times 3 is 9, giving us 4 plus 2, which is 6. 6 plus 9 is 15. So the true statement, 15 is equal to 15, confirms that these are the correct values for x, y, and z. So the solution to the system is the point where x is 2, y is -1, and z is equal to 3. And that is how you solve a system with the substitution method. Let's now have you try a few practice questions. Solve by substitution and check the answer. Question number 1. Equation A, x plus y plus z is equal to -3. Equation B, x minus y minus z is equal to -3. And equation C, 3x plus 2y minus 2z is equal to -5. Question number 2. Equation A, x plus 2y minus 3z is equal to -15. Equation B, -2x minus y plus 2z is equal to 6. In equation C, 3x plus 3y plus z is equal to -3. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. Step 1, isolate x on the left side of equation A. To do so, we want to subtract y and subtract z from both sides, showing us x is equal to -y minus z minus 3. And now that we have an expression for x, step 2, substitute x into equations B and C, here and here. So we'll plug in -y minus z minus 3 here. That gives us -y minus z minus 3 minus y minus z is equal to -3. So we can combine our like terms. -y minus y is -2y. -z minus z is -2z minus 3. And now we just want our y and z terms on the left side. So we'll add 3 to both sides, showing us -2y minus 2z is equal to -3 plus 3, which would be 0. So this is equation D. So we'll put that to the side. And now we plug in our expression for x into equation C. So we get 3 times -y minus z minus 3 plus 2y minus 2z is equal to -5. So we begin by distributing this 3 to each of these terms inside of the parentheses, giving us 3 times -y, which is -3y. 3 times -z is -3z. And 3 times -3 gives us -9, plus 2y minus 2z is equal to -5. And now we combine our like terms. -3y plus 2y is -y. -3z minus 2z is -5z. Minus 9 is equal to -5. And now we add 9 to both sides, giving us -y minus 5z is equal to -5 plus 9, which is 4. So now we have equations D and E, our 2x2 system. So we can use the substitution method on this 2x2 system to solve for these two variables, y and z. So we want to move equations A, B, and C to the side for a moment and work with just D and E. So now for equation D, we want to isolate y on the left side. So we'll add 2z to both sides, giving us -2y is equal to 0 plus 2z, which would be 2z. And to remove the coefficient -2, we divide both sides by -2, showing us y is equal to 2z divided by -2, which would be -z. And now that we have an expression for y, step 5, substitute y into equation E here, and then step 6, solve for z. So that gives us -1 times -z minus 5z is equal to 4. -1 times -z is positive z. Z minus 5z would be -4z, and that's equal to 4. So now we divide both sides by -4, showing us z is equal to 4 divided by -4, which would be -1. So now that we've solved for z, step 7, substitute z into equation D here, and then step 8, solve for y. So that gives us -2y minus 2 times -1 is equal to 0. -2 times -1 is positive 2. So now we'll subtract 2 from both sides, giving us -2y is equal to 0 minus 2, which is -2. And to remove this coefficient of -2, we'll divide both sides by -2, showing us y is equal to -2 divided by -2, which is +1. So now we've found the values for both y and z. Y is +1, z is -1. So now, step 9, we can substitute y and z into equation A, B, or C to solve for x, step 10. So if we plug these values into equation A, we would get x plus 1 minus 1 is equal to -3. +1 and -1 cancel out, showing us x is equal to -3. If you substituted y and z into equation B instead, that would have given us x minus 1 minus -1. Minus -1 is +1, so that cancels out -1, leaving us with just x. So again, we get x is equal to -3. Or you could have chosen to plug y and z into equation C to solve for x. If you did so, you got 3x plus 2 times 1, which is 2, minus 2 times -1, which is +2. 2 plus 2 is equal to 4. So we get 3x plus 4 is equal to -5. And to solve for x, we'll subtract 4 from both sides, giving us 3x is equal to -5 minus 4, which is -9. And now we divide both sides by 3 to give us x is equal to -9 divided by 3, which is -3. So when you plug in y and z into A, B, or C, we get x is equal to -3, showing us the solution to this system is the point where x is -3, y is +1, and z is -1. And now, step 11, check the answer by plugging the x, y, z, -3, 1, and -1 into the original equations, A, B, and C. When we plug them into A, we get -3 plus 1, which is -2. -2 minus 1 is -3. So we get a true statement, -3 is equal to -3, confirming that these are the correct values for the variables. When we plug them into equation B, we get -3 minus 1 minus -1, which would become +1. -1 and +1 cancel each other out, leaving us with just -3 on the left side. And this true statement, -3 is equal to -3, confirms that these are the correct values for x, y, and z. And for equation C, we get 3 times -3, which is -9. 2 times 1 is +2. And -2 times -1 is +2. -9 plus 2 is -7. -7 plus 2 is -5, giving us the true statement, -5 is equal to -5, confirming that we found the correct values for x, y, and z. So the solution to this system is the point where x is -3, y is +1, and z is -1. So that is the answer to question number 1. Let's now have a look at question number 2. We were given the 3x3 system. Equation A is x plus 2y minus 3z is equal to -15. Equation B, -2x minus y plus 2z is equal to 6. And equation C, 3x plus 3y plus z is equal to -3. So step 1, isolate x on the left side of equation A. To do so, we'll need to subtract 2y and add 3z to both sides, showing us that x is equal to -2y plus 3z minus 15. And now that we have the expression for x, we want to substitute x into equations B and C here and here, so that we can create a 2x2 system with variables y and z. We'll distribute the -2 to each of these terms inside of the parentheses, giving us negative 2 times negative 2y, which would be positive 4y. Negative 2 times positive 3z is negative 6z. And negative 2 times negative 15 is positive 30. Minus y plus 2z is equal to 6. And now we want to combine our like terms, giving us 4y minus y, which is 3y. Negative 6z plus 2z is negative 4z. Plus 30 is equal to 6. And now we want to subtract 30 from both sides, showing us 3y minus 4z is equal to 6 minus 30, which would be negative 24. So this would be our equation D. So we'll put that to the side, and now we'll substitute x into equation C here, giving us 3 times negative 2y plus 3z minus 15 plus 3y plus z is equal to negative 3. We'll distribute the 3 to give us 3 times negative 2y, which is negative 6y. 3 times 3z is equal to 9z. 3 times negative 15 is negative 45. Plus 3y plus z is equal to negative 3. And now we can combine our like terms. Negative 6y plus 3y is negative 3y. 9z plus z is 10z. Minus 45 is equal to negative 3. So now we want to add 45 to both sides, showing us that negative 3y plus 10z is equal to negative 3 plus 45, which would be positive 42. So now we have the 2 by 2 system that we will use to find y and z. So we want to move a, b, and c to the side for a moment so that we can work with d and e. And now we'll isolate y on the left side of equation D. So we'll first start by adding 4z to both sides, giving us 3y is equal to 4z minus 24. And now we'll divide both sides by 3, showing us y is equal to 4z over 3 minus 24 over 3, which would be 8. So now that we have our expression for y, step 5, substitute y into equation E here. And then step 6, solve for z. So when we plug 4/3 z minus 8 in for y, we get negative 3 times 4/3 z minus 8 plus 10z is equal to 42. And now we distribute the negative 3. The negative 3 and the positive 3 cancel each other out to give us negative 1. Negative 3 divided by 3. So we get negative 1 times 4z, which is negative 4z. Negative 3 times negative 8 is positive 24. Plus 10z is equal to 42. We combine our like terms, positive 10z and negative 4z, to give us positive 6z. Plus 24 is equal to 42. And now we'll subtract 24 from both sides, giving us 6z is equal to 42 minus 24, which is 18. And now we divide both sides by 6 to give us z is equal to 18 divided by 6, which would be positive 3. So now that we have solved for z, step 7 is to substitute z is equal to 3 into equation D here. And then step 8, solve for y, giving us 3y minus 4 times 3, which would be 12, is equal to negative 24. We'll now add 12 to both sides, giving us 3y is equal to negative 24 plus 12, which would be negative 12. And now to remove this 3, we divide both sides by 3, giving us y is equal to negative 12 divided by 3, which shows us that y is equal to -4. So now we've found that z is 3 and y is equal to -4. So step 9, substitute y and z into equation A, B, or C to solve for x. So I'll show you all three of these. So when we plug in y is equal to -4 and z is equal to 3 into equation A, we get x plus 2 times -4, which would be -8, minus 3 times 3, which is -9, is equal to -15. -8 minus 9 is -17. So we wind up with x minus 17 is equal to -15. And now we add 17 to both sides, showing us that x is equal to -15 plus 17, which is +2. And we'll get +2 for x if we substitute y and z into B or C as well. So if you chose to plug them into B instead, you would have gotten -2x minus -4, which would be +4, plus 2 times 3, which is 6. 4 plus 6 is equal to 10. So we get -2x plus 10 is equal to 6. And now we subtract 10 from both sides, giving us -2x is equal to 6 minus 10, which is -4. And to cancel this -2, we divide both sides by -2, giving us x is equal to -4 divided by -2, which would be +2. So we get x is equal to +2 again. And you'll get the same value if you chose to plug y and z into equation C instead, giving us 3x plus 3 times -4, which would be -12, plus 3 is equal to -3. -12 plus 3 is -9. So we wind up with 3x minus 9 is equal to -3. And now we add 9 to both sides, giving us 3x is equal to -3 plus 9, which is +6. And now we divide both sides by 3, showing us x is equal to 6 divided by 3, which is +2. So the solution to this 3x3 system is the point where x is 2, y is -4, and z is +3. And now step 11, check the answer by plugging the x, y, z, x is 2, y is -4, and z is 3 into the original equations. When we do so, for A, we get 2 plus 2 times -4, which is -8, minus 3 times 3, which is -9. 2 minus 8 would give us -6. -6 minus 9 is -15. Giving us the true statement, -15 is equal to -15, confirming that these are the correct values for x, y, and z. For equation B, we get -2 times 2, which is -4, minus -4, which would be +4, so these cancel each other out, leaving us with 2 times 3, which is 6. 6 is equal to 6, confirms that our x, y, and z are correct here. And now for equation C, we get 3 times 2, which is 6. 3 times -4 is -12, plus 3. 6 minus 12 is -6. -6 plus 3 is -3, giving us a true statement, -3 is equal to -3. Confirming that we had the correct values in all three equations, and thus the solution to this system is the point where x is 2, y is -4, and z is 3. So that is how you would solve a 3x3 system using the substitution method. Let's wrap up the chapter by discussing how we solve a 3x3 system using the elimination method. Now for the elimination method, what we will do is we will use the first two equations to eliminate one variable, our x, and then use the last two equations, b and c, to eliminate the same variable x, and that will leave us with a 2x2 system with the other two variables, y and z. And then once we have this 2x2 system, we will use the elimination method on the 2x2 system to solve for the two variables, y and z. And then we'll use back substitution again to substitute y and z into our original equations to solve for the third variable x. So let's use this system and go back to the beginning and walk through it step by step. So you'll be asked to solve by elimination and check the answer. Equation A, x plus y minus z is equal to 2. Equation B, x minus y plus 2z is equal to negative 3. In equation C, 2x plus 2y minus z is equal to 1. So step 1, if we're working with A and B, what we want to do is subtract equation B from equation A. We do not need to multiply either equation by anything since we have x in both. So if we subtract equation B from A, we're able to eliminate our x variable, which is the goal. So we get y plus y, which is 2y. And we get negative z minus 2z, which would give us negative 3z. And 2 minus negative 3 would give us positive 5. So equation D is 2y minus 3z is equal to 5. So we'll put equation D to the side, and now we'll take a look at equations B and C. And in order to eliminate our x variable, we want to negate 2x and negative 2x. So we'll multiply equation B times negative 2. When we do so, we get negative 2 times x, which is negative 2x. Negative 2 times negative y is positive 2y. Negative 2 times positive 2z is negative 4z. And negative 2 times negative 3 is positive 6. And now step 3, add the equations. Negative 2x and positive 2x cancel each other out. 2y plus 2y is 4y. Negative 4z minus z is negative 5z. And 6 plus 1 is 7. So now equation E is 4y minus 5z is equal to 7. So from this, we now have our 2x2 system that we will use to solve for y and z. So now we use the elimination method on this 2x2 system. So step 4, we want to multiply equation D times negative 2. When we do so, this will give us negative 4y, which will cancel out positive 4y. And we also get negative 2 times negative 3z, which is positive 6z. And negative 2 times 5 will give us negative 10. So now step 5, add the equations. Negative 4y and positive 4y cancel each other out. 6z minus 5z is positive z. Negative 10 plus 7 is negative 3. So we get z is equal to negative 3. So now that we found the value to one of our variables, step 6, we can substitute z is equal to negative 3 into equation D or E. You can plug it back into either one. And then step 7, solve for y. So if we plug negative 3 for z into equation D, we get 2y minus 3 times negative 3, which would be positive 9, is equal to 5. And now we subtract 9 from both sides, giving us 2y is equal to 5 minus 9, which is negative 4. And now to remove this coefficient of 2, we want to divide both sides by 2, showing us that y is equal to negative 4 divided by 2, which would be negative 2. We will get the same value for y when we plug z into equation E, giving us 4y minus 5 times negative 3, which would give us positive 15, is equal to 7. And now we want to subtract 15 from both sides, giving us 4y is equal to 7 minus 15, which would be negative 8. And now we want to divide both sides by 4 to remove this coefficient of 4. Again, showing us that y is equal to negative 8 divided by 4, which would be negative 2. So we have y is negative 2 and z is negative 3. So now we can solve for x. So step 8, plug y and z into equation A, B, or C, and then solve for x. So if you plugged y and z into A, you would have gotten x minus 2 minus negative 3. Minus negative 3 is positive 3. Negative 2 plus 3 is positive 1. And now we subtract 1 from both sides, showing us x is equal to 2 minus 1, which is positive 1. And we'll get the same value for x if we plugged y and z into B, which would have been x minus negative 2, which would be positive 2, plus 2 times negative 3, which is negative 6. 2 minus 6 is negative 4, giving us x minus 4 is equal to negative 3. And now we'll add 4 to both sides, again showing us that x is equal to positive 1. Or you could have plugged y and z into equation C, giving us 2x plus 2 times negative 2, which is negative 4, minus negative 3 would be plus 3. Negative 4 plus 3 is negative 1. So we get 2x minus 1 is equal to positive 1. And now we add 1 to both sides, giving us 2x is equal to 1 plus 1, which is 2. To remove this coefficient of 2, we divide both sides by 2, showing us that x is equal to 2 divided by 2, which is 1. So we get x is equal to positive 1, regardless if you plugged y and z into A, B, or C, showing us that the solution to this system is the point where x is equal to 1, y is equal to negative 2, and z is equal to negative 3. And now, step 10, check the answer by plugging the x, y, z, x is 1, y is negative 2, and z is negative 3, into the original equations. When we plug them into A, we get 1 minus 2 minus negative 3, which would become positive 3. 1 minus 2 is negative 1. Negative 1 plus 3 is positive 2, giving us the true statement 2 is equal to 2, which confirms that these are the correct values for x, y, and z for equation A. For equation B, we get 1 minus negative 2, which is 1 plus 2, plus 2 times negative 3, which is negative 6. 1 plus 2 is positive 3. Positive 3 minus 6 is negative 3, giving us the true statement negative 3 is equal to negative 3, confirming that these are the correct values for x, y, and z for equation B. And equation C, we get 2 times 1, which is positive 2, plus 2 times negative 2, which is negative 4, minus negative 3 is positive 3. 2 minus 4 is equal to negative 2. Negative 2 plus 3 is positive 1, giving us the true statement 1 is equal to 1. And since we wound up with 3 true statements, that confirms that the solution to the system is the point where x is 1, y is negative 2, and z is equal to negative 3. So that is how you would go about solving a system with the elimination method. Let's now wrap up the chapter by having you complete a few practice questions. Solve by elimination and check the answer. Question number 1, equation A, x plus 2y minus 2z is equal to -1. Equation B, 2x plus y minus 5z is equal to -1. Equation C, x minus 4y plus z is equal to 11. Question number 2, equation A, x minus y minus z is equal to 8. Equation B, 2x minus y plus 4z is equal to 1. And equation C, negative 3x plus 2y minus 3z is equal to -9. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. So we'll begin by first working with equations A and B. So to eliminate our variable x, we want this term to be -2x. So step 1, multiply equation A times -2. This will give us -2 times x, which is -2x. -2 times 2y will give us -4y. And -2 times -2z will give us +4z. And -2 times -1 will give us +2. So now we can eliminate our variable here, because -2x and +2x cancel each other out when we add the equations. So step 2, add the equations, giving us -4y plus y, which is -3y. 4z minus 5z is -z. And 2 plus -1 is +1. So equation D is -3y minus z is equal to +1. So we'll put this to the side. And now we'll take a look at our last two equations, B and C. So we have 2x in B and +x in C. So that lets us know that we'll want to multiply equation C times -2. So that's our third step. -2 times x will give us -2x. -2 times -4y will give us +8y. -2 times z will give us -2z. And -2 times 11 will give us -22. So now we can eliminate our x by adding the equations, giving us y plus 8y, which is 9y. -5z minus 2z would be -7z. And -1 plus -22 is -23. So equation E is 9y minus 7z is equal to -23. So now we have the 2x2 system that we'll use to solve for y and z. So in order to eliminate our y's now, we'll want to multiply equation D times 3 so that we get -9y. So let's take a look at D and E and multiply D times 3. When we do so, we get 3 times -3y, which is -9y. 3 times -z will give us -3z. And 3 times 1 will give us +3. And now step 6, add the equations. That will allow us to eliminate y, giving us -3z minus 7z, which is -10z, is equal to 3 minus 23, which is -20. And now that we've eliminated our y variable, we just have z. So step 7 is to solve for z. So we'll divide both sides by -10, showing us that z is equal to -20 divided by -10, which is +2. And now that we've found z, we can substitute z into equation D here, or equation E here, and then step 9 will be to solve for y. So if you plugged in 2 here into equation D, you would have gotten negative 3y minus 2 is equal to 1. So we'll begin by adding 2 to both sides, giving us negative 3y is equal to 1 plus 2, which is 3. And now to remove this coefficient, negative 3, we divide both sides by negative 3, showing us that y is equal to 3 divided by negative 3, which is negative 1. And we also could have arrived at this value for y by plugging z is equal to 2 into equation E instead. That would give us 9y minus 7 times 2, which is 14. And that's equal to negative 23. So we'll add 14 to both sides, giving us 9y is equal to negative 23 plus 14, which is negative 9. And now we divide both sides by 9, showing us that y is equal to negative 9 divided by 9, which is negative 1. So now we've found that y is negative 1 and z is positive 2. So step 10, substitute y and z into equation A or B or C. And then step 11, solve for x. So if you chose to plug y and z into A, that would give you x plus 2 times negative 1, which is negative 2, minus 2 times 2, which is negative 4. Negative 2 minus 4 is negative 6. So we get x minus 6 is equal to negative 1 for equation A. And now we add 6 to both sides, showing us that x is equal to positive 5. And you would get the same exact value for x if you chose to plug y and z into equation B instead, giving us 2x minus 1 minus 5 times 2, which would be negative 10. Negative 1 minus 10 is negative 11. So we get 2x minus 11 is equal to negative 1. And now we will add 11 to both sides, showing us that 2x is equal to negative 1 plus 11, which is positive 10. And now we divide both sides by 2, giving us x is equal to 10 divided by 2, which is positive 5. We would get the same value for x if we plugged y and z into equation C instead, giving us x minus 4 times negative 1, which would be positive 4, plus 2. 4 plus 2 is equal to 6. So we get x plus 6 is equal to 11. And now we subtract 6 from both sides, showing us that x is equal to 11 minus 6, which again shows us that x is equal to 5. So now we found the solution to be the point where x is 5, y is negative 1, and z is positive 2. And now step 12, check the answer by plugging the x, y, z, 5, negative 1, positive 2, into the original equations. When we do so, we get 5 plus 2 times negative 1, which is negative 2, minus 2 times 2, which is negative 4. 5 minus 2 is 3. 3 minus 4 is negative 1, giving us the true statement, negative 1 is equal to negative 1, confirming that these are the correct values for x, y, and z for equation A. And now for equation B, we get 2 times 5, which is 10, minus 1, minus 5 times 2, which is 10. 10 minus 10 give us 0, leaving us with just negative 1. And the true statement that negative 1 is equal to negative 1 confirms that these are the correct values for our variables. And then equation C, we get 5 minus 4 times negative 1, which is positive 4, plus 2. 5 plus 4 is 9. 9 plus 2 is 11, giving us the true statement that 11 is equal to 11. And since all three equations were true with these values, that confirms that the solution to question number 1 is the point where x is 5, y is -1, and z is +2. So that is the answer to question number 1. Let's now have a look at question number 2. We were given the 3x3 system. Equation A is x minus y minus z is equal to 8. Equation B is 2x minus y plus 4z is equal to 1. And equation C is -3x plus 2y minus 3z is equal to -9. So we'll first take a look at equations A and B. And in order to eliminate x, we'll need to multiply equation A times -2, giving us -2 times x, which is -2x. -2 times -y is +2y. -2 times -z is +2z. And -2 times 8 is -16. And now step 2, add the equations. This will allow us to eliminate our x, leaving us with 2y minus y, which is +y. 2z plus 4z is 6z. And -16 plus 1 is -15. So equation D is y plus 6z is equal to -15. So now we'll put this to the side and take a look at equations B and C. We see here we have 2x, and here we have -3x. So we'll want to multiply equation B times 3. This will give us +6x. And step 4, we'll want to multiply equation C times 2. That will give us -6. That allows for +6 and -6 to cancel each other out. So let's go ahead and work that out. 3 times 2x gives us 6x. 3 times -y is -3y. 3 times 4z is 12z. And 3 times 1 is 3. And for equation C, 2 times -3x is -6x. 2 times 2y is +4y. 2 times -3z is -6z. And 2 times -9 is -18. And now step 5, add the equations. That will allow us to eliminate our x variable, leaving us with -3y plus 4y, which is +y. 12z minus 6z is +6z. And 3 minus 18 is -15. So that gives us an equation E of y plus 6z is equal to -15. And that happens to be the same as equation D. So now when we try to eliminate our y variable, which would require us to subtract equation E from equation D, we get y minus y to eliminate our y's, which would be 0. But then that also leaves us with 6z minus 6z, which is 0. And -15 minus -15 is plus +15, which would give us 0. So we wind up with the true statement, 0 is equal to 0. And that lets us know that there are an infinite number of solutions to this 3x3 system. So once you hit this statement here, you are done. And you know that there are an infinite number of solutions to this system. And that wraps up this chapter on 3x3 systems. Should you have any follow-up questions, feel free to leave them in the comment section. Or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.